Hi students, welcome to my course module on process plant operator training using a simulator program. Okay, I hope you went through my previous videos. For the newcomers, I strongly recommend you to go through my earlier videos, which is of 10 to 15 minutes of duration, because I made videos such a way it interests you, so that I didn't made a 1 hour or 2 hour kind of videos which will make you a bit tired in watching a single video. So whatever the 12 or 13 videos I have made, just go through those videos and don't jump into the present video directly. Okay, I just watch it, otherwise you can't able to understand the process, what is happening, what are the, because we have discussed about the level controls, pressure control, what is split range controls, what is ratio control, what is the feedback, what is feed forward, what is cascade controls, and these are the different controls we have discussed. The once we jump into the present process, and you won't be able to understand unless you go through the previous videos. Okay. And well, anyway, welcome to video. Today we are going to discuss on the control of a distillation column. And let us go to the simulator mode to understand more about the process. Okay, the moment you open the screen of the distillation column, you are going to find this way. The objective of this distillation column is to separate propane from butane. Okay, the initial composition of the propane in the mixture is 36.19%, and the exit composition, from the distillation, the overhead composition of the propane is 97.21, and the bottoms composition is around 0.22% propane. Okay, the objective is to purify, separate the propane from the butane using distillation column. C001 is the distillation column in which the feed is going through a feed pump through a control valve, and once the feed enters, the separation is going to take place. This is what the reboiler, you can see the reboiler is going to, using steam. Normally they reboil, they maintain the temperature of the reboiler is 103 degrees centigrade, so design temperature. At the present condition, the distillation column is operating at 17 kg per centimeter square. Okay, and this is called the overhead condenser. It's air cooled condensing systems. Once the overhead is condensed through this air cooling condensing systems, it enters into the reflex drum. You can see this is the level of the at the present state, the level of the reflex drum, and finally through the reflex drum, few of the stream is sent back to the column as a reflex, and few part of the stream is taken out as a product. You can see this is the product. The flow rates and everything were given. You can see 190 meter cube per hour of flow is going in at this present moment, and exit is 100.83 meter cube per hour, and the exit from here and this from the bottoms is 81.79 meter cube per hour. Okay, this is what the overall idea, and this is what the control jobs comes in play now. And let me give you a small picture because it's a bit bit confusing for you. Let me go to the simple diagram, flow of direction. This is what happened. Some feed is going into the distillation column. This is the reflex drum. Okay, this is a reflex. This is the reflex. This is a reboiler. This is a reboiler, and this is the bottoms product, which is butane, and the overhead stream, which is called propane. Okay, it is cooled through the air cooled systems. Okay, presently the second pump is off because our requirement is not bigger. So if the requirement goes higher, we are going to operate the second pump here. Presently there are two pumps that are operating. One is to send out the feed, and second is to send, to taken out the product from the reflex drum, and as well as to send the reflex to the column. This is what happening. Let us go to the DCS. And important, you can see what are the different controls here. What you see, the level control, because let me check. Okay, this is the basic control. Okay, once the required level 50%, you can see the moment you touch this, there is some controller window is getting opened. You can see presently the 50% set value and the process value is equal to 50%, because I have to maintain the level at the 50%. Accordingly, the valve opening is 41.56 manipulated percent. I'm talking about this particular. That means this is how we are going to maintain the level in the reboiler through this valve. It is simple level control. Okay, let us come to the other controls now. Here you can see the feed. You can see the feed is controlled through this particular control. What is this? This is going to set value is 190, the process value is 190. Accordingly, accordingly the manipulator, the value is now 50.02% open. Because to maintain this 190 meter cube power, the valve opening is 54.0, because this is a flow controller. That means it will control the flow into the distillation column. This comes under flow controller. Okay. Then now we have discussed, because today we have discussed, this is the flow controller, this is a level controller, and imagine this is called pressure controller. Level. You can see presently the column is operating at 17 kg per centimeter square. Imagine they follow this dotted line. This dotted line, it will split into two parts. One goes to the fans, which is first and last fan, and second signal goes to this particular flow. Imagine whenever this kind of split system is called split range control system. Where we have discussed about the split range control system in the earlier videos. What is the job of the split range control? Beyond certain signals sent by this controller, up to 50%, the fans will be operating. Okay, it will control the speed of the fans. That means if there is a less vapor is coming, a less fan speed is going to indicate. If more vapor is coming, it is more fans are going to get operated, because to condense the overhead vapor. What happens beyond 50% control? That means it is beyond the capacity of the fans to condense this particular overhead vapors. What happens? It is going to open this particular valve to flare. Okay, this is the main job. Split range control system is, it will try to control the overhead vapor. Beyond this overhead vapor, okay, presently it is beyond. That means it is a valve is operate. The signal is 8.6%. That means it is beyond 50%. How it is indicating how much is beyond 50%? Because this valve will be operated between the control range of 50 to 100%. Now 50% signal is already sent to this cooler. Beyond this 50 is 8.6% go to the valve. For this 8.6%, 1.86 kilo normal meter cube per hour. This is the flow rate that goes through the flare system at this moment. Okay, this is called split range control system. We have seen flow controller here, level control here, and split range controller here. What else is level? Another level control. You can see the exit, the product which we withdraw from the reflex drum depends on the level. You can see the level. Now it is maintaining at 50% reflex drum level. The moment the more vapors are coming in, level is going to raise. Accordingly, the level control system is connected to flow controller. You can see this is called cascade operation. You see, this is the primary controller will send a signal to this secondary controller. This secondary controller will decide the opening of this particular valve. So this is, when you touch this, you can see this particular symbol. That means this particular control is cascaded. That means you don't have control to set the set points of this particular secondary controller. Only you can able to set the set points of the primary controller, which will at this presently 50% is the set value. So according to the 50%, it will decide the set value around 100.83 for the secondary controller. So if I change my set point, let us say 60%, presently it is 50%. If I change my set point to 60%, so my secondary controller will be, accordingly it will be decided. Why people go for the cascade control system? I told you, better control, because level control is a lazy control systems to make it much active, and so that the secondary, because it will measure the flow, accordingly it will control the, because please go to my cascade control system to know about it. That means presently you have seen this is particular cascade. This is called cascade control system. Okay, and this is very simple. You can see the reflex. It is not connected to anywhere reflex drum. It is simply a more reflex you want to send. You can simply control. Presently the reflex is going in 162 meter cube per hour. If you wanted to increase the reflex, automatically you have to give the more set value. Accordingly the reflex is going to raise. Okay. This is it is simple flow controller. Okay, it is simple flow controller. And the main important part, you can see feed forward and feed backward. If you remember the video on feed backward and feed forward, imagine finally you have to control this steam to the reboiler section. This is steam jacket, but this is what you have to control the flow to the jacket, which will heat the this particular reboiler drum, no, you have to heat up this liquid. Accordingly, you have to send a steam through a jacket. A pipe will goes in where it is get heated up through a surrounding jacket steam. So you see this. This is the particular. This is a control. It is receiving signal from the two people. One is flow. What is the objective? Is to control the temperature. You can see the objective is to control the temperature in the reboiler. So to do that, it will control this particular flow. Okay. See, it receives the signal from feed, because this is called feed forward. It receives, because how you're going to increase the steam flow? If the more feed is going in, accordingly it will receive the signal that more feed is going in. Now I have to increase my steam requirement to cater the needs of the higher feed flows. That means whatever the signal that comes from here, that is called feed forward signal, because before the disturbance is reaching the column, it will take an action. Okay, that is why it's called feed forward. What is the second one? Feed backward. What is the feed backward? And once it feed goes in, it will changes, because it is, what is this? This is measuring the temperature inside the reboiler. So once the more feed is getting into the column, so some temperature changes happens. So accordingly it will receive the signal. That means after disturbance has been taken place, it will measure the temperature. Then it will correspondingly, it will send a signal to this particular valve. That is called feed backward. One signal is coming from the feed forward, another signal is coming in the feed backward. So both will try to control this particular valve. So it is feed forward as well as feed backward connected to the cascade system. See, the moment I choose valve, this symbol is coming. This symbol is nothing but cascade. That means this is the main controller that will decide the set point of this particular controller, which will control the flow. Okay, you can see how many things are involved. Now, if you don't follow my earlier lectures, everything will be hazy for you. That is what is presently happening. So imagine, this is the entire operation that looks like. Okay, there are some, because they have to connect each and everything. This is in industry, these are the things normally that will going to take place. One is split range control systems, level control systems, cascade control systems, feed backward and feed forward control systems. Sometimes you can see the changeover switch. That means if I click here, that is presently it is connected to feed forward and feed backward systems. I can change only feed backward. I don't want any feed forward. Okay, let me start this particular valve. Let me understand how I'm gonna change. I can, if a moment I touch, now it will receive the signal only from this particular sensor which is measuring the temperature. That means feedback systems. Now it won't take any signal from this particular line, which is called feed forward systems. So sometimes during initial stages of operation of a distillation column, it is better to go for the feed forward, so that it will try to settle the things much faster. Okay, once this distillation column is close to steady state, you can switch this to the feed forward and feed backward systems. Okay, let me now presently it is operating under steady state, and the things are everything fine. In addition to that, what you are going to observe, these are another things, trips. It is important for a pump to go off under certain conditions. It is important for the steam flow to be stopped at certain conditions. It is important for the reflex pump to stop at certain conditions. Those are called trips. Let us observe what are trips. Imagine this is called C001 column, and this is the TIC 001 indicating the temperatures in the reboiler, and there are different aspects. So there are some trips that is designed for the pumps to go off for the safer side. Let us see what are the trips that are given. See, whenever it is MOV 001, that is steam supply. Okay, when the steam supply goes off, there are three conditions. Okay, when temperature temperature is beyond the set point, TIC 001 is greater than 130, the steam supply is going to be off completely. Second thing is pressure. If presently the pressure in the distillation column is 17 kg per centimeter square, once it goes beyond 19, so steam supply is going to get off. Okay, And because more is the pressure and less, what happens, the pressure is going to get raised if you supply more amount of heat, because even when the pressure, when the distillation column is already operating at higher pressures, if more steam is going to supply, so steam, the column pressure is going to rise because of the higher vapor generations. So that is it. And third is level control, LIC. When this is called reboiler level. Okay, when's the reboiler level in the distillation column? Let me show you. This is the reboiler level. This is panel. Okay. When this reboiler level is less than 20%, there is no need of steam requirement to what is the material that is there inside for you to heat. That is a concern of reboiler. When there is a no level in the reboiler, then what is necessary for to supply the steam? It is going to get tripped. Okay, these are the trips. Okay, you have to. And second is pump, P003. What is P003 here? Let me go to the DCS. What is P003? Yeah. This is P002 and this is P003. Okay, this is P003. Okay, this is and under what such conditions the pump is going to get tripped? Let us see the trips. Low level in the reflex drum. When the level in the reflex drum is less than 10%, so automatically the pump will go off. Okay, this is the trip set for the pump, P003. What is the and what is the second is bottom product flow, MOV002. What is MOV002? Let us go to the DCS. This is MOV002. That means the outlet flow from the bottoms. When it is going to be right now it is open. That means some flow is happening through this particular valve. So when it is going to get tripped, bottom product flow. Okay, when low level in the C001. Okay, when there is a low level, that means when the reboiler level is less than 20%, so there is no requirement for you to send the things out from the reboiler. So when the reboiler level is less than 20%, automatically the bottom product flow, MOV002, will be tripped. Okay, that is what this is bottom product level. This will complement the reboiler level is less than 20-30% what is specified. This will be get closed. Okay, what is the requirement? There is, if there is low level in the reboiler, what is the things you are going to send out then? What are the another trips? And feed pump, high level in the C001. When the LIC001 is greater than 90%, the feed pump will trip. What is LIC001? If you go to the DCS panel, this is the LIC001. When this level level is more than 80-90%, automatically the column is got filled with the liquid. Okay, what the necessity for you go to pump more amount of things inside? So automatically the feed pump going to get off once the level is reached more than the specified. These are the different trips. Normally whenever you go to the any chemical industry, you have to go through these logics, trip logics. Okay, when a pump is going to get off, when the valve is going to get closed, when the steam supply is going to get stopped. These are the trips that are given in such a distillation column. You all have to understand this. Okay. Hope you went through various aspects. Now looking at the distillation column, now you're going to get an idea where to use level indicator, where to use level control, pressure control, flow control, split control, cascade control, feed forward and feedback control. All these things, you can see huge amount of things are going on just to distillation column. Imagine you're operating the entire plant. How many controllers will be required to stabilize the plant? What you are looking at is a simple distillation column here. Okay, see how much amount of trips are involved. See the moment, let us say, if you wanted, you can play with the simulating environment in much better way. Imagine I wanted to, as you have studied in the class, if you increase the more reflex, into the column, the 97.21, the purity, whether it is increased or decreased, you're gonna understand. Okay, see the moment I reduce this particular flow, reduce the reflex, see what happens to my purity of the propane in the overhead vapors. Okay, you can do that simple in this. Right now it is operating in the steady state. Imagine what happens. I reduce these reflex. Okay, whenever you try to deal with the distillation column, don't try to alter it. Don't give a very wide no set points. Okay, if you, because distillation going to get react even with the smallest flows that goes into the column. Okay, try to alter it in a very slightest possible way. Imagine the set value is 162. Now I am going to get 155. See what happens. The purity you can observe that the dynamics, I mean, are a bit tricky here. So earlier in 162, I have reduced the reflex, to the column. See what are the other parameters. Okay, see the level has got dropped 50% to 49.9 because less amount of fluid is going back into the column. Accordingly, the level is going to get reduced. See my purity. How the purity, because the moment I reduce the flow, you can see the level of the reflex term got raised because I have restricted the flow here. If I restrict the flow here, automatically the level is going to raise in the reflex drum. Accordingly, it will send a more signal to the this particular valve. Now it is going to allow more flow to go outside to maintain the particular level in the distillation column. Okay, you can observe various dynamics here. Okay, the and you can see the more amount of flare in the system. You can see the flare. What happens to my flare is, and the more amount of fluid is going in, the pressure got raised 17.08, and so accordingly you can see higher is the pressure, higher is the flare, because pressure has got increased. Accordingly, the more bore head vapors are coming in. So there are some dynamics that are happening inside the column. You can able to observe, just like in a real plant, what are the things to touch, what are the things to operate, where exactly before you go, and you need to see the tags. Okay, these are the design values. Presently the process value you can able to observe. Okay, what happens if you change the pressure? Okay, imagine the moment I change the pressure, what is happening, you observe here. Presently the column is operating at around 17, and so let me increase the pressure. Okay, 18. Okay, let me increase the pressure. See what happening. The moment I increase the pressure, what is happening? Okay, you see, because to increase the pressure, the outlet flow of the vapor has to be reduced. So accordingly, you can see the valve is closed here. So the more now the pressure has been raised, you can see the level, because less amount of fluid is getting condensed. There are some issues that came in because of the rise in the pressure. What is the PIC 001 high? Okay, that's what happening. PIC 001 right now it's a higher situation. See the things, because to increase the pressure I have to reduce the condensation. Because I have reduced the condensation, automatically the level is getting dropped. Okay, accordingly my flow, you can see, my flow will not as such affected, because my flow is this particular flow is affected by the two signals. One is coming from here, and second, see the temperature, because you have restricted more amount of, see what is happening, the rise in temperature is happening. Okay, because the pressure, because the controller, no, it's a dynamic operation. So what is the things, you can able to observe many things at one possible time. Today what you have seen is a design mode, because we are trying to alter the things which is already at a what happens, no, operating at a steady state. Next thing which we can able to can discuss about the cold start. Cold start means nothing will be there. You have to start the pump, you need to fill the reflex drum, you need to do everything. Okay, I hope you understood the basic concepts of what are the trips, what is a simple, flow. It's a without control operation, simply to make you understand the flow is going from here. Some flow goes to the reflex, some flows, this is a reboiler, this is the bottoms, this is the overhead vapor. So this is covered today, and hope you have went through. One second. Yeah. Hope this is what in industry, what people sit in the computer screen and try to operate. Okay, thank you. This is Dr. Surendra signing off.